We have all been there. Untangling this mess feels much better, right? Well, this is what working with forum data feels like. A forum is a collection of posts. Usually we know the time they were posted, but how are they related? This could make sense, but this also makes sense. Our aim is to find meaningful reply chains in conversations. We therefore need to untangle the threads of a forum. We present ThreadReconstructor, a visual analytics approach for untangling and comparing different threaded conversations. Since different threads have different characteristics, we need a variety of techniques to untangle them. We therefore combine trained classifiers, user-defined queries, and heuristics. To reconstruct a particular discussion, we might want to choose a combination of all three techniques, creating a model. Through applying this model on a discussion, we can reveal the different reply chains of the conversation. In a second model, we choose to only apply two techniques and get a set of different reply relations. Our thread reconstructor approach does not only allow us to explore the results of the two models, but also to compare them, highlighting their agreement. However, some models are better at reconstructing the ground truth than others. Our visual analytics approach allows us to reconstruct threads, untangle conversations, and diagnose different models. We first start with extracting and weighting features from the conversation transcript. These features are used by the users to generate different reconstruction models. Previously saved models can be loaded back into the system. We compare the results of the different models to present them in the visualization interface. This is the main interface the users see and interact with. During their exploratory analysis, the users can generate new models which are loaded into the workspace. These trigger a new cycle of analysis and can be saved back into the database. Now let's take a look at the different components and start with the feature extraction. We categorize messages into 10 different groups. These are, for example, short messages, others containing special characters, messages by highly active authors, and yet again others containing quotes. In addition, we extract reply relation features that indicate the likelihood of a connection between two different messages. These are content features, such as a high topic agreement, structural features, such as the mention of the same quote, and meta features, such as the time distance between the two different posts. Using the extracted features, we allow users to create different reconstruction models. In the model generation step, users can choose from a set of classifiers, create their own queries, and apply heuristics on the data. They can also choose a name for their model to save it. In the remainder of this video, we will showcase the usage of our tool through the lens of the visualization interface. The examples shown are inspired by our user study with 4 forum moderators and 1 machine learning expert. Our visual analytics workspace consists of 4 views. The text level view is designed for close reading and detailed inspection. The reply relation view is designed to gain an overview of the complete conversation. The thematic forest view untangles the conversation into different connected components. Lastly, the parent candidate view is used to inspect the decision space of the models. The text view is the first view the users see. It shows the complete text of the conversation and highlights the relations created by the left and the right model. In addition, users can explore single relations or select a post for a detailed inspection. Closing up the text panel, this view transitions to become the reply relation view. Using the sidebar, users can generate new reconstruction models from any view of the system. Any saved model is automatically available to choose as left or right model. In the reply relation view, users can investigate different connections and compare models through their agreement. In order to analyze different reply chains, users can choose one model and open up their thematic forest view. All connected components are based on the selected model and can be sorted according to their number of posts. Hovering over a tree shows common features, words, and phrases of its posts. In addition, users can choose to open a small text view for a focused analysis of the selected tree. In order to analyze a model in more detail, users can take a look at its decision space. This last visualization reveals all parent candidates a model has considered for every child in the conversation. The parent candidates are ordered in columns according to the internal ranking of each model. Zooming out on the whole view reveals global patterns. For example, the zigzag connections typical for random forest models. Hovering over a path reveals all parent candidates for a selected child node. It also highlights the feature distributions of these nodes. To reduce visual clutter, we can focus the analysis on a subset of relations by using the slice and dice interaction. In order to optimize the thread reconstruction, users have the option to save relations. For example, by selecting various parent candidates. All saved relations are stored and can be shown as a combined model. We have presented our Visual Analytics workspace, which is designed to optimize thread reconstruction. Since thread reconstruction models are typical black boxes, difficult for the users to tune, we visualize all considered parent candidates for every model. This is taking the model tuning task from the model space to the model decision space. As an instance of a model decision space visualization, our parent candidate view clearly revealed differences in the inner workings of machine learning algorithms. Random forests, which are more robust to overfitting, showed more stable visual patterns. We presented ThreadReconstructor, based on a tailored feature extraction and a user-driven model generation. Our visual analytics approach presents different visualizations for model comparison, untangling discussions, and understanding model decision spaces. Thank you for watching this video.